And we are live. Hello, everyone. This is the webinar about Kafka and Kotlin. I'm here with you today, Anton Arkhipov, developer advocate from JetBrains. And I have Viktor Gamov with me, a developer advocate from Confluent. Hello, Viktor.
Hi, Anton. Hello, everybody. Welcome to this live stream webinar. I guess we're all doing these live streams right now. No traditional webinars because we're going live on YouTube and
yeah, we are going to do this live stream style.
Yeah, I see quite a chat in the
have
chat
a lot
YouTube.
of comments from Brazil, from Sweden, all over the world. People are joining us today. So, what are we going to talk about first? I would like to make a small intro. So this is the first webinar in the series that we have today, but we are also going to host two more webinars in December and January, running Kotlin in Google Cloud with James Ward and developing backends with Kotlin and Spring Boot on Google Cloud with Ray Tang. So these webinars are more about showcasing Kotlin for server-side development because Kotlin is an awesome language for this task. And today we are going to start with Kafka. So without further ado, I think we are ready to go live with explaining what Kafka is, why it's awesome, and how to apply Kotlin for this task. Over to you, Viktor.
All right, thank you very much, Anton. So it's great to be here, and I was thinking like how I can approach this task instead of just just telling you something. I would rather show you something. And today you will see mostly live coding and some of the live presentation rather than some slides. So I think that's the only place where you will see some of the slides and things like that. So you can find me on Twitter. My name is Viktor Gamov, and I am a developer advocate in Confluent. First thing that you need to know about me, find me on Twitter. You need to find me on Twitter and follow me there. If you are want to have some chat with me, you can find me on Telegram. I also run a small YouTube channel where I do live streams every Wednesday, and I run bigger live YouTube channel at the Confluent where I run live streams every Tuesday. And today we're gonna be doing some cool, interesting stuff. So I was thinking, Anton, instead of again doing this traditional presentation and talking things, I would rather start coding something, and you can interrupt me and ask some questions if something is not it's not very clear. And today I'm going to be using the a little bit like few sprinkles of Spring framework with Kotlin that allows me to help that will help me to explain the concept of event streams, concepts of Kafka, and how the things are working in the Kafka world. How about that?
Viktor, one second. Could you check your mic, please? Someone is saying that it's like broadcasting mono instead of stereo.
It might be broadcasting mono instead of stereo. It's possible, but this is something that I probably can change in settings if I will go here and um, disable. And I'll do stereo audio. How about now, folks? On the other side, YouTube, what do you see? Is it better now? Did I change it? How about now? Is it better now?
People say it's better. People say it's better.
Okay.
Okay, let's proceed.
Yeah, I think the system just switched the microphone from mono to stereo, from mono to stereo. Anyway, if you want to geek out about audio equipment,
some people are saying it's worse now. I don't make
worse.
up your mind, people. Yeah, it actually is working on the left side for me.
You can hear only one channel or
yes, one channel.
Let's just disable this in all. Let's do this one. How about now?
Now it's perfect. Now it's perfect.
Now it's perfect. All right.
Yes.
That's that's why you know this is not pre-recording. They know this is a live stuff. All right.
Live stuff.
Okay.
What could go wrong?
Yes, exactly. Everything could go right. So nothing could go right. So we're doing this Gradle, Kotlin, all things 2.4 Spring Boot. Anton, I heard that Spring 2.4 now includes Kotlin 1.4. So I decided, okay, let's use it, all right?
Yes. Brand new.
Confluent.developer. So first up, like why I'm using this package, why I'm using this package name, because this is the very cool website where you can start learning Kafka in all things around stream processing called developer.confluent.io. And we can talk about this later, but remember these three words, developer.confluent.io, your place about learning Kafka. And today we're going to be doing, since it's a Kotlin webinar, we will do this one. Now, why I'm using Spring Boot? I'm using Spring Boot because it allows me to bring some of the dependencies that I need in one place, and it's pretty awesome. So if I go here and I just do some Kafka, if I do here, I do Kafka one more time, and I see there's Kafka streams. We're going to be talking about this one as well. What about Kafka again? So Spring Cloud Stream is a very interesting project that I also would like to use. Since it's a 2020, and there's everyone is talking about reactive, I also will be using reactive because I heard that YouTube algorithms will try to find the videos with reactive in it, and it will promote those better. And usually
Hype-driven development.
exactly. And let's use this one. Oh, I'm sorry. We're not
No,
gonna use this one
Lombok.
this
We
time.
don't need Lombok.
No, we're in the Kotlin, right? We're not using Lombok anymore.
Of course.
All right. So we do have a couple things, and the Spring actually simplifies some of the Kafka work, so I would like to focus on actual aspects of the Kafka programming rather than just showing you like tons of configurations and things like that. So how about this? So we would just do generate. I will go in my folder. I will just quickly unzip it, and it's okay if you don't see it because you will see my ID in few seconds. And so let me use Eclipse today. So while Eclipse is starting, I will. Okay, I'm just kidding. We're using IntelliJ. We're not using Eclipse today. All right. So what's the folks saying in internet? So how they seeing this so far? Kotlin is starting, Gradle is building, and sweet. So we do have our test application, this test application working, and this is where we're going to start. All right, let's start with the first thing. One of the things that people usually want to do when they're starting with Kafka, they want to send messages into something. Before you can start reading, you need to provide some of the data that you want to put there. So for that, I will be using this small bean that will be producing some of the cool things. But those cool things,
what did you do? How this code appeared immediately? That was some kind of a trick.
it was some kind of a trick. No, it's actually not trick. It's called productivity, Anton. And this productivity trick, actually, I learned from you. So back in the day when you were doing some of the presentations around IntelliJ, you showcased some of the live templates. And I said, wow, live templates is actually pretty cool for live demos. Instead of just me typing stuff, I do have this live template that will produce some of the Chuck Norris quotes. But before that, let's get into my dependencies and add something very important and very useful for this presentation. Specifically, we can produce as many as hello world messages as we can, but what about we produce something meaningful? So in this case, to produce something meaningful, we do have this guy. So this is an incredible library. If you folks don't use this, it's called Java Faker. It's a library that allows you to use some of the pre-generated things for your application. Like I was running out of ideas whenever I'm presenting something and like going with something like a full bar, blah, blah, blah. I decide, no, the full bar is not fun. So we will do Chuck Norris quotes. So I have this live template that allows me to generate this small bean that will produce something for me. And let me fix some of the imports, and we're talking about messaging, and everything is here. So let's talk about this. So this bean is a function that produces a supplier. And what is a supplier in a bigger sense for Java developers? Supplier is something that, every time when you invoke the method get from supplier, you get something. So in this case, this concept of kind of functional approach was taken into some very interesting place by framework developers. So Spring Cloud Streams folks decide, okay, so what about we will bring some of the kind of like a function-based development, more like a, when you focusing on actual logic. And what this logic will do, it actually produce message to Kafka. But you can say, Viktor, there's nothing here to say we need to use Kafka here, right? And there's nothing that says that we're going to use the Kafka. And this is done because our Spring Cloud Streams friends, they designed this concept of binder that allows to decouple your application code from the code that will be dealing with the low-level transport of the data. So this is why let's configure this. This binder first. Usually, I don't use YAML, but today I will make an exception. So another live template hack that allows me to activate. And I also was thinking, like, well, I can use this local host, and it's kind of fun and stuff. But what about if I will use something that's not running my laptop? Especially when you do live streams, you want to use this bandwidth and the laptop power to showing some of the nice increased picture, but not slow you down of running some infrastructure on your laptop. So we're going to be using some cloud, but in a second we will talk about this in just a few seconds. Let me uncover it and also fix indentation. Another good thing, when you're dealing with YAML, you need to use the right editors that can understand indentation, otherwise you will be screwed. Now, so let's talk about this. So we do have this Spring Cloud Stream function definition, and this is how the Spring Cloud Stream will find the method that it will invoke in order to do something with this data. And there is a binding that will create this connection to my Kafka broker that is specified in Spring Kafka properties, and specifies that this is what kind of binder I need to use and where I need to produce those messages. So we're going to be looking into a topic called facts. Number of partitions is 4. Use native encoding says that I will provide my serializer, deserializer. So here's the thing. Kafka really don't care about what kind of data you're putting there, but as a developer, you really do care about what kind of data you're putting there. So this is why you need to specify the serialization format. Kafka doesn't do introspection. Kafka just stores raw bytes. Yes, sir?
Vic, can you increase your volume a little bit?
My volume, of course, I can.
Yeah, people are complaining.
Now?
People are complaining.
What about now? What about
perfect,
now?
Perfect.
Yeah?
Yes. Do.
Awesome. Okay, all right. So thank you for monitoring. Thank you for monitoring this the audio stuff for me. All right. So where are we talking? Where we were? So we define this function, definition of the function. So this Spring Cloud String will find this bean, and after that we'll make all this wiring to Kafka. And now I also want to have some of the clustered job. So I do have this Confluent Cloud, which is my cloud provider of my Kafka. I'm creating some basic cluster that will be running in Google Cloud close to me. I'm in New York, so US East would be closest location for me. And I would say lunch cluster. So when I started this cluster, so what's going to happen is that the cluster of Kafka would be created somewhere. And in order to get this access, so I need to go here and find the Spring Boot. And there is a template that I can use for my property file. Like I said, I usually use property files because it's more natural. But today I will be using YAML because there's nice ring to it, because there's so many things it can be nested like this. So a couple things. I need to grab this Bootstrap server that will define a ending entry point of my application. So my application would know to connect to this server. So I'm putting this here. And another thing, I need to have a key and password to connect to this one. So we go in here, I create a key, create the local key. Next, I will say copy this one, and I say Kotlin webinar. Kids, don't do this at home because right now I'm broadcasting the internet some of the passwords, and usually you don't want to do this. But hey, try to.
There was a good question in the chat, I think, worth answering right now. So currently we are using the cloud version of Kafka. We are not running it locally, right? But what if someone wants to run Kafka somewhere in their own server and they want Docker images? Do we have Docker images for Kafka?
Yes. So in the best place, as you would know, is to find example how you can use these Docker images is to go to developer.confluent.io.
Exactly.
In developer.confluent.io, you will find a section tutorials and examples. And if you want to do something like a very basic consumer producer basic, there is a tutorial for that. And in order you to execute this this tutorial, for some reason my link is not
a
clicking.
Universal answer. When in doubt, go to developer.confluent.io.
Yeah, and I will go to, for some reason a link is not working, tutorials. It will bring you to this the Kafka tutorials website. Is it me or it's something is funky is going on here? cnfl.io tutorials. I have a shortcut that brings me to this tutorial. So my Chrome, for some reason, froze.
Okay. Well, we can just give a pointer. Actually, people will find it. Anyway.
So essentially,
go there.
If you go in there, there would be the place where we can grab this Docker Compose. And this Docker Compose with 20 lines will give you, Zookeeper, it will give you Kafka, and it will be ready to use on your local machine, so you will be able to connect your application from localhost. So in this case, you can do things like this. In configuration, you just need to put Bootstrap server, localhost, and something like that. So that will work.
Perfect.
Right? So yes, the Docker images are there, and they are available to you to use. Now, all right, so we do have these things here. We have this nice, funny function main that we will be execute, and let's see if we will get something working. So my application, my Spring Boot application is starting up. It's connecting to somewhere.
And just to mention, if there is an image, like a Docker image for Kafka, it means actually that you can use test containers for integration testing, right? So you don't really need embedded Kafka, right?
Yes. So you can do something like this. If you go to my GitHub, which is also one of the places where I am, and I will go to my repository. You can find tons of examples how to use this in this particular repository called TestContainers, Confluent platform. That includes Kafka. That includes some of the other components that we'll not be discussing. So if you go here, you will find, say, src test, Java, and for example, we want to see how we can test producer and consumer. And there's a Kafka container from TestContainers in the scheme registry that works together with Kafka. So, all right. So it's there. So while we were talking, something is happening. So there is a producer that was able to connect to my cloud cluster, and some messages went somewhere. Let's take a look where these messages went through. So I'm open this topic facts. Remember what I was saying, we have this topics of facts with 4 partitions that we designed. So in this case, it turns out into actual topic with 4 partitions. So what is a partition? So partition represents a append-only file. Essentially, it's the file on the file system where all the messages will go in the format of just like a write into the end of the file, and we can talk about the read, but you usually read from beginning of the file. And the reading is sequential. Kafka topic is a combination of those partitions or a combination of those files. And those files can be distributed across multiple nodes. In this case, it runs in the cloud. I believe default configuration, it will run in 3 nodes. So these partitions will be spread across multiple nodes of the cluster. It allows to build like a distributed and high throughput system. So, but we are right now only interested in some messages. And as you can see, those messages are actually coming into, those messages are actually here. And we see some of the interesting facts about Chuck Norris's life. So Chuck Norris doesn't need OS. Chuck Norris, only pattern Chuck Norris knows is a God object, okay? And, you know, some other things. Now, it's an UI. So it's a great when we have this in our UI, we can see what is going on here. But what about if we need to have this access to do the same stuff programmatically? And before I jump into this one, I want to show you last thing. So my application actually uses this producer, and data will be produced into the Kafka topic. As we can see here, we see how those messages are spread across multiple nodes. We can see some of the bits around throughput, how the messages land here, and things like that. But in general, one of the things that you want to remember is that we have a producer that writes data in Kafka topic. And we don't have anything on other side except my UI that reads this data. But let's bring this my application that will be reading this data from somewhere. And to do so, I need to bring another bin here. That bin will use the same, or not the same, similar interface, interface consumer. So let's take a look on this one. Every time when we call the accept method of the consumer, something will land into as a parameter, and this is what framework will be invoking. So framework will invoke a method accept, and as a result, the message that will be generated from the consumer or received from the Kafka consumer will be injected in this method to process this. So don't mind this nice ASCII art that just allows me to have some of the fun in the console and use some of the formatting in my ASCII art. So we will expecting that the message in string format will land. And as always, as we see in the previous example with the producer example, let me copy this one real quick. So I do have the consumer configuration that will be replacing this part. All right. So one of the things that you might find here is that I'm adding another function definition. So the Spring Cloud Streams knows about this this method. So we do have a produce Chuck Norris that will represent to my function that provides supplier. And this is my consume method that provides a consumer. And this is where we actually configure this. So my group sounds kind of lame. Let's call it something cooler. For example, Kotlin affects outputter.
Kotlin. You have a typo there. Yeah.
Facts outputter. So in this case, it's our application that will be reading messages from the topics, and as we see the logic is simple. We just have something printing out into somewhere out to out.
System print one.
Yeah, and I see like I did. Yeah, I can use the Kotlin the string interpolation instead of just like doing concatenation. But hey, let's do this one. Another thing that we need to configure here is a producer and producer properties. We did this for producer. So in this case, we need to know how to turn these objects, that string object and another string object, into bytes. And this is how we're using this serializer. Same thing we need to do when we're reading. We need to tell consumer, hey, we know that the items there are strings because by default it uses bytes and so far and so on. So let's see. I'm just quickly restart this, recompile and restart this application. So we will get another component of this application. We will get a hopefully we'll see some of the consumer messages that come into the console. And 3, 2, 1. Our consumer. And see, so many messages. Anton, Why don't you
Yes.
ask me, like, Victor, why we do have so many messages here?
Why do we have so many messages here, Viktor?
So it's a great
Because of
question,
check
Anton.
our. Actually, yes. Like, what happened? You have been restarting the application. We shouldn't be generating that many messages yet.
Yeah, that's a great question. As a matter of fact, this is one of the questions that people usually ask when they see something like, what's the difference between Kafka and messaging system, right? Because with the same mindset that just, or the same question that Anton usually asks, is just people asking, what about like my application will not be up when this message arrives? Do I need to ask someone to resubmit those, and how does it work? And the cool thing about Kafka is actually your application, or maybe not even be written at the time when the message was produced, but you still want to deal with this data. And let me show you quickly how does it look like from perspective of data.
So let me check that. Like, did I get it correctly? So for the first time when we launched the application and we only had the supplier running, basically generating, producing the messages, and now when we started the application for the second time after the restart, we actually got all those old messages into our consumer.
That's correct. And the way how it works, is Kafka provides not only a messaging pattern when you can, submit the message topic and read this on our side, but also Kafka provides a durable storage. So your data, once it's produced, it's safely stored in a file system, and also replicated across multiple nodes in case of failure of individual nodes. So in this case, it behaves more like a database. And let's take a look on something interesting here. So there is a thing called an offset. So as you can see here, there is I'm just looking, look into new messages that come in here, and my offset is growing. And offset also growing within partitions. So I have 4 partitions, meaning that I have 4 different files. And inside this file, I have a pointer of last message that I wrote here. So in this particular case, this message in file number 1 or partition number 1 stored under index 134. And this number is actually growing. If you can see here, this number is actually growing. So the way how it works, let me bring data flow real quick. When my producer produces some data, and this data doesn't have a key, so Kafka would say, okay, so there's no key. In this case, I will just like balance this equally across all partitions. So it will randomly pick up partitions, so it'll have a normal distribution of this data. Now, on the other side, we do have a consumer. And the way how the consumer works, see, it's our Kotlin facts outputter. This is our consumer that reads data and writes data into console. And this consumer also know where it starts reading data or where it stops reading the data. So what happened with our consumer, since we're starting this application, and this application was not available during this producing of these messages, and there's a configuration says auto offset reset earliest, meaning that during the startup of this application, my consumer will go and find earliest available offset. In this particular case, there was no offset, and will read the messages from the very beginning. So think about this. If you're doing this, writing new application that will be processing this data, which we will do in a few moments, we will writing some of the processing logic different from the logic of just simply outputting data into console. You need to have all this data. And in the messaging world, what you would do, you will call your friend who responsible for messaging infrastructure, saying, hey, John, could you resubmit those messages through the topic? I need to test something. Write down in the comments if you've ever been in a similar situation when you're trying to emulate some of the load that happened in the system, or have a production-like data going through the messaging system. With Kafka, you don't have to do this because your data is already there, and you can actually programmatically set the point. You can send the offset where you want to start, because there's another configuration called latest offset, what means that when my application will start, it will read only messages that arrive during the startup or whatnot. So as you can see, it catch up with some of the old messages and now continue to speeds out this data out here.
We actually have a lot of questions coming in, so probably makes sense to take some of them.
Let's do
Alexei
it.
is asking about the pace of the supplier. Can we limit how many messages it actually generates? I think it does it make sense in case of Kafka actually to limit the supplier, because the
Um,
goal of the
yes.
of the middle, or I was about to say middleware, but
No, it's still totally legit name. Middleware it
okay.
is. Yeah.
Right, but the goal of middleware is actually to receive everything that it is being supplied with, right? So we don't
Yeah.
want to drop messages.
So the cool thing is that as far as I tested in some of my research, so you can actually configure this, or you can even implement something like reactive producer, where you can limit in how fast this supplier will send the messages. There's a ways how you can tune how often these messages will be sent to actual Kafka topic, for example, because there's a configuration that allows you to define like a size of the batches, like actual the packets that will go over the network. So short answer is yes, you can. There's a
And
configuration
maybe
that
and
available.
maybe you would like to have more partitions then as well, right? To be able to consume more concurrently.
Exactly. So Anton brought a very good point. And so what we see right now in this particular case, we have 4 partitions. And the way how Kafka deals with this type of situation, let's take a look on this consumers tab. So in the consumers, my application right now will create 4 instances of consumers. So each consumer that will be, spitting out this stuff on the console will be running in my application. So each consumer will listen only particular partition. So my application right now just like have this, the reading all these partitions. And if you like, imagine a situation where you have a mommy bird, mommy bird, and she has say 5 worms that she brought up to feed the baby birds. So, and currently there's only 2 baby birds hatched out of the egg. So what gonna mommy bird will do? She will try to equally distribute those worms across these 2 baby birds. So she will give 3 to one baby bird, and she will give 2 to another. So when a baby bird will hatch, mommy bird will stop process of feeding, and again will try to equally redistribute this load. So it will give the 1, 1, and 2, or like a 2, 2, 1 rather, to another, because we have a 5, right? And what's gonna happen, Anton, if we have 5 worms, but we have 6 baby birds that hatched?
Someone will have no worm.
Exactly. So the same thing, the reason, the purpose of this talk that I'm trying to explain, this is exactly how Kafka consumers work. So you have in your topic, you have 4 partitions, so you can have 4 parallel consumers that will be constantly reading this data from this
And this
topic.
is managed transparently for you. You don't have to specify to which partition your consumer is connecting, right?
Yeah, that's correct. And the reason, only thing that as a developer you're responsible in specifying this consumer group. So consumer group is basically your nest. You're specifying this nest where you have a group of your friendly consumers are sitting. So based on this consumer group, when your application starts and connects to this Kafka broker, it says, hey, I'm in this consumer group like a Kotlin fax outputter. And in this case, it will go, okay, hold on. So let me check if there is any other consumers that consuming something from in this group, to consuming some of the partitions. If there are, you will join this and you will get your own part that you will be dealing with. If there would be more consumers than topics, so in this case, one of the consumers will be just like idling. And it's totally fine situation, because sometimes you want to kind of over provision, and in future you will be able to change the number of partitions. You can extend, change the number of partitions inside the topics. There's some implications. I'm not going to go very deep on this one, but yes, you can do this, and it can be changed after you create a topic. But in this particular case, in our particular in our particular case, we have a one producer that writes data into this topic and writes across all these partitions. And we have a one consumer that will read all these messages. Everything will go into this application, all right? Now, there are some good things apart from the reading some data from the console. Let's do some processing. And we know that there is a kind of like a holy grail of holy grail of all examples in the world of big data or fast data is what? Is
word count. Word counting.
Exactly. Exactly. So we
Let's
will do
count
the same.
the words.
We will do the same, and we will do this. We can do this also writing another consumer. Can we? Yes, we can. Because in the consumer, we get the message.
And the consumer can be another application, right?
Exactly. And it can be another application. It can be absolutely another service running, you know, outside of the our JVM. So, but the thing is, when I will do this with another consumer, the programming part will be a little bit cumbersome. So I need to think about this like, okay, so I do counting. When I do counting, I need to know what was the message count before I count in a new incoming message. So I need to store it somewhere. Well, we can store this somewhere in the JVM memory, but like, how about if application will fail and we will lose this data? So in this case, we can store this in the file system somewhere, maybe in files. Now, there's many things you need to start like asking yourself when you're trying to write a, you know, stable or like a the fault-tolerant stream processing system. Consumer is a good start to do so, like to do some basic things. But why not just use this framework that, you know, part of Apache Kafka? And of course, I'm talking about Kafka Streams. So Kafka Streams is a Java library that has nothing to do with clusters, nothing to do with your, you know, it's not your grandfather processing cluster. You're writing your application. You want to write the service. You want to write your logic. You don't want to think about, you know, the clusters and how I just deploy my job, and if this job will fail, how this will be rescheduled and things like that. You're writing apps. So let's do that. So I'll just do another step in our pipeline that will bring this thing called Kafka Streams. And quickly fixing some of the, all right, here we go, create extension method, import. I'll just import and Kafka Streams. We will fix that as well. Import, and produced. Import. Okay, so this is what we have, and let's take a quick look at what is going on here. So we know. Oh, let me put the configuration, and after that I will explain something. All right. And as always, I need to check my all right, good stuff. Now, we're adding one more thing. So we do have a producer, we do have a consumer, and now we have a processor. So let's take a look how the processor is different. So Kafka producer, this is our consumer, and now we do have this, where's the streams binder? Stream bindings, and binder. So we do have this binder that will be connected to Kafka, and there's another binder that will be connected to like would represent the configuration for Kafka Streams. Now, it's my application ID that also would be represent some of the consumer group and things like that, and something like this. Now, there's something interesting. There's this weird word called Surday. What the hell is this? So remember in the consumer and producer example, I showed you that for when we're writing data into Kafka, we're using serializer to take these strings and turn them into stream of bytes. And for consumer, we take this stream of bytes and we turn this into our object. Now, if I see here, we have another functional interface. We have a supplier, we have a consumer, now we have a function. And how a function is different? It has a method that receives some value and it has some method that returns some value. So in this case, it fits very well in the concept of transformation because we need to get something, do something with it, and get the result back. So we're reading something from Kafka topic, we're doing something with this, and we're writing something with Kafka topic. So in this case, we need to have a combination of this serializer, deserializer. So in this case, it's basically, if I will go here, it's just Serday is a kind of interface that API built on top of that allows you to specify pair of serializer, deserializer in order this application can use this. Right. Next thing, this thing looks like more, I don't know, like the operations on Java collection rather than some of the stream processing. And this is exactly it. So Kafka Streams comes in two flavors of these APIs. The Fluent API, or in some literature, it's also referred to as a DSL, which I don't want to call DSL because it's not entirely true, in my personal opinion, of purists, DSL theorists. It looks like more like a Fluent API, where we build some of the things kind of like a step by step. And the first thing that we're reading this input stream. You see, this is our input stream that we're receiving here. And the Kotlin is actually helping us here to make a point. Remember, when we write this data, we didn't specify any key. So there's a potential null keys, and Kotlin allows us to kind of specify this explicitly. Next thing is that we need to get this every message that will consist of the sentence that represents a fact about life of Chuck Norris. And in this case, I need to split this into sentences, and after that give this words to another step in my pipeline. So here's the thing. So this the flat map values is actually returning. If I will go here quickly, the flat map values actually return another stream that represents a the like exploded version. And similar to other flat map implementations, instead of giving kind of like a stream of streams or stream of lists, because it will require additional serialization, deserialization, things like that, it's actually explode. For the stream of messages, it will return bigger stream. So for each message, for each sentence, it will spits out a stream of words. So when we get into the map function, where we just do some of the transformation, we already have words, individual words, and since we didn't have a key, and we don't need to use the key because there was no key, we can use this the Kotlin placeholder for this one. And now we need to turn this stream into something that will include key. And some people who never done anything around the big data tools, like maybe Spark or Hadoop or some other things, this pattern would look, very weird because, we're taking the message and now we're creating another stream where we have a key and value that would be the same word. But this is actually a very normal pattern. So first thing, you're doing this kind of like in a map reduce world, you're doing the mapping operation. You're getting the data and you're collecting this data into something, basically transforming. And this is where we're doing our map operation. We will emit a new message that we can, after that, count. Because, why do we need a key? Because we need to have a group by key, because we want to have a calculation based on a particular key, by a particular word. So in this particular case, our stream that will represent word, for example, there's word Chuck. So every time when we get this word Chuck, we will emit word Chuck. That's it. After that, we will put this in a special partition that will include only data that would be relevant for a particular key. Remember, Anton, when I was talking about this facts topic, I said there's no key in my message. So in this case, the messages will land randomly. But after a certain point, we cannot rely on some randomness stuff. We want to have some of the determined position of our data. So in this case, based on the key, when we produce a message based on the key, and if you produce a message with the same key, Kafka guarantees that your message lands on the same partition. Imagine you writing things like credit card processing, and you want to process transactions exactly how they happened. So in this case, you want to have ordering of these transactions. So how you can model this in Kafka? You can use credit card number as your key, and all messages that will be produced with credit card number as a key, they will land in the same partition, and this partition also will include all these messages that will be ordered exactly how they happened.
So
for us,
whenever we have Chuck, a word Chuck, then it always lands in the same partition, right? In our example.
Exactly. And why we need this? Because we need to have a certain processing artifact that will process this in time. So in this case, once we have this in one partition, it would be much easier to count. We don't need to go and find this chuck in another partitions. We don't need to do kind of like a random searches of this. We know that every time when the chuck is coming, we just simply like increase the timer or increase the counter. So in this case,
I'm tempted to see the result, and we only have 15 minutes left.
Oh, that's plenty of time. I will show you something else that would be also very cool. Now, so in this case, I am just to go into my thing, and I will just rerun this.
So now we have two producers, or we have one producer and two consumers, right?
Correct. And we have some, but function definition is not properly set. Let me see. Let me stop this. Let me see if I process words. That's correct. Let's do this one more time. It might be something to do with YAML. I'm pretty sure I messed up with the YAML. The good thing is that let's just do. This is YAML, correct? Binder streams. That's correct location. And I would put this cloud thing back, and I'll just do Spring. That should do. Let's see. YAML sometimes helps to streams. Yeah, that should do. And my was a Kotlin. Kotlin
facts outputter.
Yeah, facts. All right.
And you deleted the cloud, didn't you?
Oh, no, it's still there.
All right.
I'm using the folding thing. Let me see if I will be able to run this again. Let's see. It's always it's always fun to work with the YAML and things like that.
Can you actually do that without YAML programmatically? There was a question in the chat.
Yes, you can do this in the programmatically. There's a whole bunch of examples that I have around this, how we can do this without like YAML and configuration. Function process words. Okay, so let's see if I do have YAML. Let's debug it. Let's see. Process words. We have this definition. Now we do have and the definitions here. So we have this process words here binding. I think there's might be the problem with this. It's a good thing is that I do have a working example where I can take a look because never go anywhere without have a properly formatted YAML. I might mess up with these bindings. So bindings, we do have a correct bindings, Kafka, binder, streams, binder. Yeah, looks like it. And you know what? I will just go ahead and copy it from here because I know this
cloud key was deleted.
No, it's all right. So everything is here. I really that's why I like a live streams type of setting. Is the people are so helpful, and I really appreciate this. And people always trying to help and suggest some of the ideas. That's why I like do kind of like a live streams and things like that. So let's see if I already so with properties in the stream, I need to use the ruler. In order to get this, I get the properties in cloud. Cloud should go into, who said cloud? Cloud. like this. This word, right? So in this case, we
Line
do have
12.
Kafka. Yeah,
Okay.
now it should do the thing. Cloud string function. Cloud string function, definition, bindings, producer, bindings, producer, binder, okay. Let's get back our Kotlin outputter facts. All right, so let's give it a shot. Folks, say with me, like the holding the fingers.
Yep.
Fingers crossed.
Fingers crossed.
Fingers crossed. Yay! And
Ta-da.
something is working.
Something is
Folks,
working. Okay.
YAML
it was
rules.
YAML.
Folks, YAML is the thing that will screw up your live demo. Let's take a look. Now we're going back to data flow and we see some of the counts. And let's see messages that go into this topic, and we see some counts. The value is something not quite sure what is value.
It's not rendering.
Yeah, and Anton, this is where you're supposed to ask him, like, what the hell, Viktor?
Yeah, what the hell? What the hell, Viktor? Where are the values?
Okay, so let's take a look on this thing a little quick. This one. So as a result of our application, we have a function that will get our stream that will include string, and as a result, it will produce another stream that will have a string as a key. It's our word, and long is our count. But you see here, it uses long serializer. And if I will drill down here, this long serializer knows how to deal, say, we need to serialize it. This is something how we can deal with long values in Java. So this serializer is actually creating some of the nonsense, the byte sequence that JavaScript frontend cannot figure out. You see, like, what does it mean W? This is how JavaScript frontend interprets some of the long output. So this is why Java serialization is not super fun and not super cool to use in the cross-platform or like a multi-language or polyglot environments when you're trying to use.
So how do you fix it?
So you need to fix this on the very beginning. You need to start using schemas. Today, we're not going to talk about schema, but folks, if it would be interesting to talk about schemas in future in Kafka, let Anton and the folks know. I can maybe return and talk about how you can use things like a protobuf here or Avro. But you know what? Since we're doing this here, and it doesn't make any sense to us for writers of this application, tell people if they want to get the count of these messages, go and read this from Kafka topic, right? We just want to, like, why we don't give you just like API? You can go and hit and get this number of Chuck Norris, okay? So let me show you one last thing that will fit in our rest. I don't know how many, like 7 minutes?
Yes.
Is it Java class or it's a Kotlin class? I wasn't sure. I didn't pay attention. Okay, let me see. Let's me recreate because sometimes it might not exactly what I wanted. IQ, REST, controller. So the Kafka streams is so cool is that it actually has a very nice tool that available you as a developer. So apart from the providing this intermediate stores into my application, would able to store some intermediate data. So in this particular case, my counts will be stored somewhere here, and this will be stored in the reliable storage. It will stored in the RocksDB. You don't know about this, but it's there. It also allows me to provide API to get access to this store to any point of your application. So you already did calculation. You already calculated this count. And over the time, you're just interested to get this result or provide this result to someone, provide some of the consumers of your application or whatnot, sorry. So in this case, I'm going here, just do a quick refresh. So I added this new REST controller that will be available through IQ/count/word. So in this case, we can test this real quick, and we always can get the right result in this case. So where is it? where's our HTTP client in HTTP client, and create HTTP request to client. That's gonna be what's gonna be we're doing. We're gonna be doing localhost 8080. 8080. So it was IQ. It was a word count, right? Count. And let's do chuck. Since I'm pretty sure that that will do. Rule no environment. Just run it. Now we see 2065 mentions of chuck. So let's run this again, and we should get the different number. No environment. Yeah. So numbers change because like it's about Chuck Norris. The number is constantly updating. We can put something else. For example, I'm interested about roundhouse kick. Only 26 times we see a roundhouse kick as would be mentioned. So let's recap real quick. So what is going on here? So this Kafka Streams application provides this so-called interactive query service that allows me to get access to this word count store and query this by key value. And this is what I'm injecting in my REST controller that allows me to turn my application essentially into API server. And before we will depart, I want to show you one last thing. So the overall application architecture and how it looks like. The point is the central part of this application. Is Kafka, and Kafka allows the multiple application to communicate through it. As you can remember, the facts topic that where our producer writes data, we have our outputter that reading data from topic and writes this in the console. But now we also have this Chuck Norris word count application. Kafka Streams includes or like wraps this consumer here. So we're reading this same data, and this data will be available for two applications. You might have another application that will simply reading these facts and dumping this into Elastic, for example. There's a thing called Kafka Connect that allows you to do this without any programming. But hey, we do programming here today. So this is why we're showing this. Now, this is Kafka topic called counts. In this count topic, we have a producer that will be writing this data to this topic. How does it work? Inside this method, toStream, or specifically this to, we're specifying the name of the topic where we want to produce results. So every time when we see this like a chuck or that will be turned into chuck1, it will be write stream into Kafka topic. Next time we will see another chuck, we will get a chuck and 2, and this result will be written in Kafka topic as a stream of changes. And using this call, we actually created in-memory representation of like a materialized view of this topic that will available for consumption. So this is why we have these producers that will be writing data into counts topic. As we can see here in terms of consumers, now we have two consumers. This is our outputter. That guy is reading this data. And there's a very interesting thing called consumer lag. And this is something that shows the difference between the offset of the message that was written in the topic and the offset that the consumer was producing. So as you can see, our facts topic is consumed fairly fast, and the data from this topic is consumed almost in real time. So consumer lag is not growing. However, let's take a look at here. So there's a couple interesting things. Our topic, the facts that we're processing, consumer lag is changing because our application do something a little bit more than just simply outputting this data into this in the console. So this is why consumer lag is growing, but not significantly. And there's another special topic that we didn't talk about this much. So let's take a look really quick. This is our topic with the sorry, not this one, previous one, this one. So this topic, state store. Remember the point where I said that if you want to be using like a hash map or like file system to store your intermediate results, there is a possibility that when the application crashes, you will lose your data. So in order to prevent this, Kafka Streams also includes this automatic replication of your state store. So essentially this count will be available, result of this count, intermediate result of this count, will be available in this special store or a special topic that will be served as a kind of like a replication point for our data. So in case of application will fail, your machine will die, your house will be on fire, data safely stored in Kafka topic. So when you restart this application in some other place, you don't need to recalculate everything. The delta, you just need to recalculate the delta, essentially, all the facts that you received before the time when the things are doing things. So that's overall view of our application. This is Kafka part. Kafka here used not only as our source of truth for our application, but also some of the intermediate and useful the component of framework itself. So to run Kafka streams, for example, you don't need to have anything except Kafka. It will be using Kafka for storing data, to reading data, and also will be using Kafka to serve some of the intermediate thing. All right, so that is it. So this is pretty much all I wanted to show you today as a kind of what word I'm looking for, as a kind of like a summary of today. So all this thing that I showed you, all this like a magic and all these things can be done programmatically. There is a Spring Boot example that allows you to use a thing called the Kafka template that will have a small wrapper around the Kafka producer. You also can use Kafka producer, but like if you get paid for number of lines of code that you wrote versus of stuff that you can accomplish in just like a few keystrokes, here's a food for thoughts for you. Like you want to be generating POJOs, or you want to use the data types and use the data annotation.
Right.
So the answer is yours, and you need to decide for yourself. My name is Viktor Gamov, and as always, have a nice day. Sorry, I'm just scared away. It's just like from my live stream. But hey,
right.
Folks, find me on Twitter if you have any questions. I gladly answer those. And you can find me every week. If you want to try, my examples and all this kind of stuff, you can use this live streams 200. It will give you like free $200 to run this in the cloud. And the cool thing about this cloud thing, you only will be charged if you're storing something, if you actually putting some data here. If I will go here in the cluster, and
basically charging for data storage, right?
Yes, it's just charging for data storage, and the friction, like how much you will pay, it would be just like, you will always get the, you always will know how much you will be charged. In this particular case, I see the number of partition, how much I use, ingress, how much meaning the how data will go in, and again, I'm using like a very basic cluster that basically doesn't cost much. You can use the better availability, but for development, this is just perfect for testing.
All right, this was fun. We had a lot of questions, a lot of requests for actually showcasing the same with Ktor. Maybe we can do another session, by writing more code instead of Spring Magic, or
yes.
Spring.
So I'm really up for this challenge. We definitely can do that.
Thank you everybody for joining us. We have 2 more webinars in this series coming up, and maybe more with Kafka as well in the future. I'm pretty sure we will have some more stuff with Kafka in the future. So stay tuned. Join us for the next webinars. Thank you, Viktor, for joining, and we are done.
Thank you. Bye. Enjoy.
Bye.